Hi, B people. Sorry about the delay making this video. No excuses, just didn't have it done yet. So here we go. Hopefully you did well here. The first one, obviously they're giving you the answer. So as far as checking your answer, you know what the answer is supposed to be. All I can say is in terms of the AP test, if they give you what the derivative should be, it's because they don't want you to be out of the rest and have to grade a messy first derivative with your work that was wrong. So it's all on you to show that you can basically communicate how the derivative comes to be. So make sure you are careful here. This is where the errors lie on the product rule and that distributing the negative. So when you take the derivative with respect to x of both sides, this to me communicates that you are using good calculus. You're taking the derivative with respect to x of both sides. Whether you showed that or just went straight to taking the derivative, that's okay, but it's preferable to show I took the derivative of both sides with respect to x. The derivative of 2x squared with respect to x is 4x, and then times the variable derivative dx is a non-issue. Plus 3y squared, the derivative of 6y for the derivative of the outside. But remember, chain rule, then times dy dx. All right, now I'm going to lump the negative 4 and the x together in the first term. So first stays the same, and the derivative of the second is dy dx. Second stays the same as y, and the derivative of the first is negative 4. So minus 4y equals derivative of 36 is 0. And now we're going to get the dy dx's together. Actually, I think looks like I'm not seeing 6's here. I'm feeling like they took a 2 out of each, so I'm going to do that next. The order in which you do these steps I'm about to do is not required the same order. It's just basically everything has to be there. So say I move all the dy dx's, let's move the other terms over. So if I group the dy dx as 3y minus 2x, dy dx's is 2y becomes positive, 2x becomes negative on the other side, and then dy dx is 2y minus 2x over 3y minus 2x, which is what I was trying to prove, right? Okay, moving on. Slope of the line tangent to the curve is 6. Find where x equals 6, not the slope is 6, dummy. All right, so, all right, I need the slope, obviously, and that's the derivative, but the derivative depends on x and y. So hopefully the first thing you did was find y. Sorry, let me give you the answer first. My answer was 2. And so if you got 2, then move on. If you understood it, that's fine, move on. But otherwise, let's talk about where 2 comes from, okay? So we need the y. If you look at the curve equation and put in an x of 6, you would get something like 2 times 36 plus 3y squared. Sorry about that. Plus 3y squared minus 24y equals 36, yeah? All right, so if I get everything on one side, I get 3y squared minus 24y, and 72 take away 36, so 36 equals 0. Let's divide out of 3, so it's easily solved. Y squared minus 8y minus 12 plus, it should be plus 12 equals 0, and so it looks like 6 and 2 are our y values. So now let's find the slope. Dy dx, when x is 6, y is 6, is 0. and dy dx, oh, sorry, there are two slopes, and dy dx at 6, 2 is 2. All right. Good notation, by the way. Use good notation. All right. Let's look at C, vertical tangent. All right. So remember, draw yourself a picture, and it helps. Vertical tangents are when the rise happens, but the run doesn't change in y with not change in x. So that means that dy dx is not 0, so it rises over 0. So dy dx, which is 2y minus 2x over 3y minus 2x, has to equal 0 in the bottom, not the top. Well, that would be then when 3y minus 2x equals 0, or y is 2/3 x, yeah? All right, cool. That's great, but now I need to find a place not only where the derivative happens, but it's also on the curve. So now you put that into the actual equation for the graph, and 2x squared plus 3 times 2/3 x. I forgot to give you the answer again, darn it. Minus 4x times 2/3 x equals 36. Eventually I got the square root of 54 out of that, if I did this right, or 3√6. Okay, so if you got that, then feel free to go on. Otherwise, let's figure out what happens. So 2x squared plus 3 times 4/9 x minus 8/3, that's squared, x squared equals 36. If I combine all the like terms, then I get 2x squared plus 4/3 x squared minus 8/3 x squared. So what do we got there? 6 plus 4 is 10/3 minus 8/3 is 2/3. X squared equals 36, so x squared is 54, and they said the positive x value, so that's why no plus or minus, all right? All right, and D. For D, I have 5 as the answer. All right, so in terms of where does 5 come from? Now, these are all differentiating with respect to time, so I need to take the derivative with respect to time of 2x squared plus 3y squared minus 4xy equals, and then take the derivative with respect to time of 36. You obviously must take the derivative of both sides, not just one side. That's math for you. All right, so taking the derivative with respect to time, now it's chain rule all over the place. So the derivative of this with respect to time is 4x for the derivative of the outside, dx dt for the derivative of the inside. Derivative of this guy, 6y for the derivative of the outside, and dy dt for the derivative of the inside. Product rule. First stays the same, negative 4x. Derivative of the second is dy dt. Second stays the same, y. Derivative of the first is negative 4 dx dt, so negative 4y dx dt equals 0. Now it's up to you whether you solve for dx dt, then substitute in values, or substitute, then solve. I'm going to put in numbers first. All right, so x is 2, dx dt I don't know. Y is negative 2, dy dt is 4. X is 2, dy dt is 4, minus 4, y is negative 2, dx dt I don't know. All right, so 8 dx dt. What's that? Minus 12 times 4, so minus 48. Minus 8 times 4, minus 32. Plus 8 dx dt equals 0. From that, I get 16 dx dt equals 50. And that's where I got 5 from. No units on that one. All right. Did that go well? I hope so. All right. Let's go to the second free response. All right. So go ahead and read this problem. Do it in 15 minutes or less, and then let's check your answers. All right. So let's check your answers first of all to the first one, f at 7. I got f at 7 is 18 minus 9 pi over 2. Do you agree? F prime at 7 is 6. If you do agree, then feel free to move on. If you don't agree, get out the red pen and let's make some corrections. So f at 7, by definition, is 3 times 7 plus the integral or area, signed area under the curve g from 0 to 7. So that's 21. And then the signed area from 0 to 7 is a negative half circle and a positive rectangle. So minus pi r squared over 2 plus base height. So that's 21 minus the radius is 3. So that's 9 pi over 2. And the rectangle is a base of 1 times a height of 3. So why did I say it was 18? It should be 24. That's weird. What was I thinking? Sorry. 24. All right. That'll be a good check to see if you really are paying attention or you're just watching the video and copying down what I do. All righty. So f prime at 7 is the derivative of 3x is 3. The derivative of the antiderivative is g. Now be careful here. That's, actually I could, yeah, well, I'll say what is the derivative and then say I'm about to evaluate. So 3 plus g at 7 is 3 plus 3. And that's where I got 6. I believe it was a solid dot at 6. Yeah, or g at 7. Oh, yeah, okay. All right. For b, I got the max value is at x equal 3. And let's see if you agree with good reasoning. All right. So when they say it's maximum value, is that talking first derivative test, f prime changes positive to negative, or is that the maximum value like absolute max? And I hope you went absolute max. Absolute max is at an endpoint or a critical number. The critical numbers of f are where f prime, which equals 3 plus g, is 0 or undefined. Well, that means I need to find where g is negative 3, and g is negative 3 at x equals 3 on the graph. Yeah? Right. Oh, gosh. Hey, look at that. Oh, man. Oh, boy. I just lost my work. All right, then. So I lost all my absolute max work, but I think you remember that g prime, g equals negative 3 at x equals 3. So now we need to find f at -4, and actually they threw us a bone because 3 is both a critical number and an n. Hello? Sorry, I got interrupted and now I need to start again. I can't remember where. I think I found the critical number, and now we're finding the y values at each critical number, all right? So our endpoints were x equal -4 and 3. We found a critical number at x equal 3. So now we're going to find f at -4 and 3. F at -4 is 3 times -4 plus the integral from 0 to -4 of g, and that is -12, and the integral from 0 to -4, well, that's crazy. Let's go change it. We need to change that so it goes from -4 to 0. And now let's talk signed areas, shall we? Looking at the graph, maybe. We have a triangle. Base height divided by 2, yeah? So, come on, baby. Base height divided by 2. So that's -12 minus the base was 4, the height is 2, divided by 2. That's -16. F at 3 is something like 3 times 3 plus the area from 0 to 3 over g, so that's 9, and a negative half circle, quarter circle, negative quarter circle, and so that's 9 minus 9 pi over 4. Now the question is, what is the most? -16 is pretty small. This is not all over 9. So this is roughly 9 minus 27/4, or 9 minus 8-ish. That's close to 0-ish, which is still more than 19, -16. So the absolute max is, now the question is, what is the max, or where is the max? And it says the value of x. And so the value of x is greatest, or the value of f is greatest at x equal 3, because it yields the greatest y value. All right, let's go to part C. What are the slopes approach as you approach 0 from the left? Now, I thought I was going to have to do definition of the derivative work, but I guess not. So if you draw tangent slopes on the left and getting closer and closer to 0, those slopes are all the same. They're the slope of the line, which is down 2 over 4. So that slope is -1/2. And it doesn't say justify, so I'm just going to go with that. What about the slopes on the right? The slopes on the right, if you draw tangent lines and say, what are they approaching? Negative, steep, negative, steeper, negative, steeper, very negative, steep. So it's approaching. These are, first of all, negative slopes and approaching infinite or vertical. So we will say that this does not exist, and that's because the slopes approach negative infinity. Okay. All right. And the last but not least, my answer to this was 1/3. If you got 1/3 and you want to move on, that's fine. If you didn't get 1/3, let's figure out why. So First thing through when we do a limit, we try and direct substitute. In anticipation of maybe L'Hopital, I'm just going to find each limit separately down here, right? So the top, as x approaches -2, this would just approach f of -2 plus 7. F of -2 is 3 times -2 plus an integral from 0 to -2 plus 7. So that's -6 plus 7. That's 1. And let's talk the integral. First, I'm going to switch to limits. And then I'm going to do signed area. I think the signed area is 2 by 1 divided by 2. And so that is 1. 1 minus 1 is 0. The top comes out to be 0, or approaches 0. The denominator, e to the 3x plus 6 minus 1, is e to the -6 plus 6 minus 1. It approaches 0 as well. So we could say then, by L'Hopital, that this limit equals, write L'Hopital in the test, x goes to -2 of, the top is f prime, the bottom is e to the 3x minus 6 for the derivative of the outside, times a 3 for the derivative of the inside, and 0. Now let's evaluate. Let's just evaluate. F prime at -2 is the same as g at -2. And this is e to the 0 times 3. And last thing is g at -2, I think, was 1, yeah? There's where my answer came from. Okay. Let's try switching gears. Try this here idea. It's got a lot of good calculus in it. It's a good mixture of you. Try this one. It should take about 15 minutes or less, and then check your answers. Okay, so here we go. The first one, again, you're showing a derivative is what it is implicitly. So you're just trying to show quality work. I started by distributing. 2x minus 2y equals 3 plus cosine of y. Before I took the derivative with respect to x of both sides. So, derivative with respect to x of both sides is 2 minus 2 dy dx equals 0 minus sine of y dy dx. Let's get the dy dx's together, so maybe something like 2 dy dx minus sine y dy dx. And let's factor out a dy dx and call it good. Therefore, dy dx is 2 over 2 minus sine y. All right? Let's go to B. Is there a place on the curve where the line tangent to the curve has... There is a place where the curve is slope 1. Find the coordinates of that point. All right. So we know that dy dx is the slope, and it's supposed to be equal to 1. So we need to find where 2 over 2 minus sine of y equals 1, which means 2 minus sine y needs to equal 2, which means sine of y needs to equal 0, and that is at y equals 0. Now the question is that, am I done? Well, it says the coordinates, yeah? So you need to do more. What is x when y is 0? So if we look back at the equation, then we would get something like 2x minus 0 equals 3 plus cosine 0. 2x equals 3 plus 1. 2x equals 4, so x equals 2. So the coordinates are 2, 0. All right. The concavity for C, if you haven't already done that, do that now. It is concave up. The curve is concave up with lots of good calculus. Now, concavity comes from the second derivative, so we need to take the derivative with respect to x of 2 over 2. Uh-oh, my internet dropped. 2 over 2 minus sine of y. And that's going to be the second derivative. Now, let's think quotient. Well, low is 2 minus sine y. D high is 0. Minus high, 2. D low is 0 minus cosine y times the derivative of the inside variable dy dx over the square of what's below. So this then is 0 minus 2. So let's see, that would be 2 cosine of y. I plug in dy dx over the square of what's below. So if I clean this up, maybe 2, 4, this should be, I might have had the wrong answer. So let's see, we have 2 times, that is 2 cosine y, 4 cosine y, come on. 4 cosine y over 2 minus sine y cubed. All right. So as far as where we're at, if the angles are between negative pi over 2 and pi over 2, then cosine has to be positive. 2 minus sine y, it doesn't actually even matter what sine y comes out to be because it can't be more than 1. So 2 minus sine y is always positive. So I think I said concave down. This is actually concave up. So we would say the curve is concave up because the second derivative is positive. All right. And then the last one. The last one required some thought, and it's a good exercise for practice. All right. So if you're like me, you read that and didn't quite know, oh boy, where it was headed. Hang on, sorry, my internet is having its issues. You probably know how this feels. Maybe you don't. I don't know. Okay, so we're on the last part, D. Come on. All right, so here we go. Now, all right, you got this function. It's continuous, differentiable. That's nice. They met the conditions. Use the mean value theorem to show that this difference must be between 1/15 and 1/5. Now, let's be clear. I have no idea what this was talking about. So I just started with mean value theorem. By the mean value theorem, there's a place where the derivative is equal to the average rate of change. Now, in this case, it would make sense to use the interval f of 2.1 minus f at 2 over 2.1 minus 2, yeah? Now, because they just have the top going on, I moved this over. So I said there's a place where the derivative times 0.1 equals f at 2.1 minus f at 2. Now I still have no idea where these things are coming from. Why must that total difference be limited? Well, if this is limited, maybe it's because this is limited. Is there any limitation on f prime? So if you look back at your work in the givens, it said for all points, the derivative is between 2/3 and 2. If the derivative is between 2/3 and 2, then 1/10 of the derivative, which is the same as f prime, must be between 1/10 of 2 and 1/10 of 2/3. Now that's 1/15. And I went to derivative notation there, or function notation there, and 1/5. Now if there's got to be a place, it must be the case that the derivative times 0.1 is between, or is equal to f of 2.1 minus 2, then I could substitute f of 2.1 minus f of 2 has to be between. All right. So that's what the proof looks like. All righty then. Good question. Last but not least, give this one a go, 15 minutes or less, and we'll go over it in a minute. Okay, so for A, I have 5 minus pi over 10. All of that over 10. For B, I have 4, and I gave you way too much room. For C, my answer was -5 to -2, or 0 to 3 with justification. And for D, I had critical points at -2 and 1. -2 was neither, and 1 was a min. All right, so those are the big ideas. Now let's get into the nitty-gritty, the details. All right, so the average rate of change. First of all, it's tempting to throw average value at this, given that you have an integral there and average word. But average rate of change is a rate of change. So you're talking g at 5 minus g at -5 over 5 minus -5. Now, I went off to the side then and found g at 5. G at 5 was the signed area. And so looking at g at 5, it is a triangle and a rectangle, both positive because they're above the axis. So that is base height divided by 2 plus base height. And I had for that 12. Okay, g at -5 was much more difficult. 1 to -5. First switch the bounds, so it's the opposite of -5 to 1. That's the opposite. Encroach in that guy's space. That's the opposite of signed area from -5 to 1. All right, so we're talking negative triangle, negative quarter circle, negative triangle. So negative negative triangle, negative quarter circle, negative triangle. Altogether, the first negative triangle was 6 minus 2 squared, pi over 4, so that was just pi. Minus the other little triangle was 1. So that is negative 7 minus pi negated, so 7 plus pi, all right? So now, working back with our average rate of change, we have 12 minus 7 plus pi over 10. That's 5 minus pi over 10. All right? And no, you cannot cancel the 5 and 10. All righty. Instantaneous rate of change of g with respect to x equals 3. All right, so it's tempting to say there's a sharp corner there, but let's actually get into it first and verify. G prime is f, and so G prime at 3 is f at 3. F at 3 is defined. It's a point. F at 3 is just 4. So it does exist. F prime at 3, that would not exist. That's a sharp turn. All right. On what open intervals G is concave up? Okay. G is concave up if G double, which equals F prime, which equals F slope, is positive. So I need to find where F is positive slope or F is increasing, and that is on which occurs on those intervals. Blank. Okay. And last but not least, almost done. Find out values where G has a critical point. Classify the critical points as max, min, or neither. All right, so critical points or critical numbers are places X is in the domain, or where you're allowed to look, where G prime, which equals F, is 0 or undefined. And that is at X equal negative 2 and 1, because the graph of F is 0 there, crosses the x-axis there. At negative 2, G prime, which equals F, does not change signs. And therefore, G prime doesn't change sign, and so there's no extrema. At 1, the graph of F, as you go left to right, which you always do, goes negative to positive. And therefore, that's a min, because that means F went decreasing to increasing, but you don't say it that way. All right, so you say at x equals negative 2, G has neither a min nor max, because G prime, which equals F, does not change signs. My handwriting's going bad at this point. At x equal 1, G has a min, because G prime equals F changes negative to positive. And boom, there you go. Is that it? All right, well, correct that and get it to me by the end of the day Friday. And tomorrow, or this weekend's homework, will be your last calculus homework for me anyway. I hope you continue on. Have a great day.